Good morning, everyone. My name is Abdul Hanan, and today I'll be presenting our project for the Virtual International Breakthrough Invention, Innovation, and Design Exhibition for 2026. Our project, which is the UAV last mile delivery in hot air regions such as the MENA region, especially Qatar, is being developed by me and my colleague Walid Mihimi, and we are being mentored by Dr. Salmiya and Dr. Abab for the control and the robotic side of the project, and we are being also mentored by Dr. Nurul for the business side of this project. These are the table of contents that will be presented in this presentation. The main issue that we're tackling is that as there's a high demand for faster food delivery services, there also is a high adoption for faster modes of transportation, such as bikes and motorbikes. However, these modes of transportation pose a high risk to the driver as well as everyone around him. Henceforth, many of the major corporations, such as Walmart, Amazon, which are goods delivery services corporation, as well as Kita in the MENA region, one of the biggest food delivery services, are trying to look for alternatives. One of the ones being autonomous aero vehicles, such as UAV. UAVs are anything like drone, quadcopters, fixed wings, rotors, any small flyable vehicle. This is the application, the scope of our project. We are selling for goods and delivery services. The main challenge that we are facing is extreme temperature, high winds, and dust, especially dust, as that can accumulate and damage the most critical parts of the quadcopter or UAV. The main objective is to deliver door to door, so from the restaurant's door to directly to the user's door. That's the main objective that they're trying to achieve. The main problem with the current solutions for the quadcopter delivery is that they're limited. They're limited to certain areas only. For the Walmart in America being only limited to certain zones, and Kita in Abu Dhabi being only limited to certain landing pads. Our main solution to this is to eliminate this, to be able to travel to the major cities, no problem at all, and to deliver to the door of a customer. These are objectives that we are following to achieve this project. We are in the last stage, selecting the best hardware as possible. These are the key literature, the most important literature review we did. Of course, there are more, however, these are the most critical ones. This is the methodology that we followed to achieve this project. We're in the last few stages. The main issue or the main thing that we want to achieve, the main requirement of this project is to achieve a stability and steady state error of tracking of 4 meters. So it should be able to follow the path within plus or minus 4 meters, and also be able to resist winds up to 15 kilometers, and on top of that be reliable by flying for more or at least 15 minutes minimum. This is the overall architecture of the algorithm. This is the mathematical nonlinear model of the UAV. This is the linear model of the UAV. These are the quadcopter parameters that we acquired from several research papers that have used similar setups. These are the way we are doing trajectory mapping. We are using A-star alongside INVENTION database, which is a government database that allows to get an accurate GPS coordinates for any of the buildings. Furthermore, we are using OpenStreetMap for a better UI. The reason we selected A-star, even though RRT was better, as you can clearly see from this table, is because of simplicity and just pure effectiveness and reliability, even though RRT, Inform RRT would have won in many other metrics. This is the LQR controller we selected. And the reason we selected this type of controller instead of PID or MPC is because of its overall simplicity and very similar performance to linear MPC and superior performance to PID. This is the tracking performance for nonlinear model on helical trajectory using the LQR controller. And this is the result, as you can see, for the 6 state variables. Very good, very less error in the angles too, as well as the position. Same for the CAD model. CAD model is not a mathematical model, rather a physics simulation model done in Simscape in MATLAB, or actually Simulink. And as you can see, similarly, very good results. It also had a package that was able to drop at the end, so you can see it's not disturbed by the package drop or the weight change. And you can see that all of them are under 4 meters. That means we are in the clear for the simulation. However, we do want to improve it. This is the best simulation we did, which is 13 kilometers traveled in 17 minutes by the linear model of the quadcopter, as well as using A-star. And as you can see, it's able to achieve it. These are all the resources required to achieve this project. We are eliminating the MATLAB and Simulink software and focusing more on ROS and Gazebo and open source variants and the hardware we have acquired. The main conclusion of this project is that we are able to achieve the model, we are able to achieve the controller, we are able to achieve the trajectory, and the overall UAV performance in the simulation is looking good. Furthermore, we are looking for B2B collaboration with big businesses such as Kita and Walmart in the future. Kita is actually present in color, so we can do it now. And this is the overall references again. Thank you so much.